Hello everyone, welcome back to my data structure series. Today we are going to learn one of the most important data structure in computer science, the stack. We will understand what is a stack, how it works, stack operations, real life examples, applications, and finally we will try to implement stack in C. Let's get started. Before learning the code, let's understand the concept first. A stack is a linear data structure that follows the LIFO, last in first out principle. This means element inserted last will be removed first. That's what LIFO mean. Think of it like a pile of books or plates arranged in order. You always place a new book on the top of the existing book. When you want one, you remove the topmost book first. You cannot remove the book in the middle without removing the ones above it. This is exactly how a stack works. Also, you can imagine you are arranging plates after washing them. You put the first plate, the second plate, the third, and so on. Now, if someone wants a plate, which plate will they take? The topmost plate, not the bottom one, right? This is why stack follows LIFO, last in, first out. The last plate placed is always the first plate removed. Look at the topmost right corner of the picture. You see something called as top. The topmost element in stack is called the top. You can imagine this to be a pointer that points to the topmost element of the stack. Here, the stack contains three elements, 10, 20, and 30. 30 is the topmost element and 10 is the bottommost element. Initially, when the stack is empty, this top is -1. When you try to push an element, say 10, 10 enters into the stack and top points to 10. Top gets incremented by 1, so now top becomes 0. Similarly, when you try to push 20, top becomes 1. When you try to push 30, again top gets incremented and it becomes 2. When you try to remove 30, top gets decremented. From 2, it becomes 1. This continues until the stack is empty. Moving on, you should know two basic things in stack. One is push, the other one is pop. Push means adding an element onto the stack. So if you say push of 10, it means that 10 is getting added into the stack. The top points to 10. Pop, removing the topmost element, is called pop. Before pop, the structure of the stack is 10, 20, 30, where the topmost element is 30. After pop, the topmost element gets removed. So now the stack becomes 10 and 20. So the topmost element now is 20. So push and pop are very basic operations in stack, where push is inserting an element into the stack and pop is removing an element from the stack. Right. Let's understand the basic operations of a stack. There are 5 basic operations. Number 1 is push. Push means inserting an element onto the stack. Number 2 is pop. Pop means removing the top element. Number 3 is peek. This returns the top element without removing it. Number 4 is empty. This checks whether the stack is empty. Number 5 is full. This checks whether the stack is full. These 5 operations form the foundations of stack. These are very important operations. The key points to remember are push is insert, pop is to remove. Moving on, let us implement stack using simple arrays. Fine. Now let us declare something called as stack and the size. Look, top is initialized to -1. Because initially the stack is empty, right? No elements are present. As we insert elements, the value of top increases. Fine. So this is the declaration of a stack. Done. Let us get into the insert operation, or otherwise in stack terminology, I call this to be the push operation. Look into the algorithm. If top equals size minus 1, the stack is full. Otherwise, increment top and insert the value. For example, if top is equal to minus 1, I push 10, top becomes 0, push 20, top becomes 1, push 30, top becomes 2. So our stack will now contain 10, 20 and 30, where 30 is the topmost element. Is it not? Yes, that is what is being coded here. I check if top is equal to size minus 1. If it is so, I am printing stack overflow. Else, I increment top and I assign value to the stack. I am inserting element to the stack. Fine. Moving on, this is my example that we have already discussed. Initially, top is equal to minus 1. I am pushing 10, top becomes 0. So the stack contains element 10. I am pushing 20. Now top becomes 1. Look at the stack. There are two elements 10 and 20. Now I am pushing 30. Top becomes 2. Fine. Right? Now there are elements 10, 20 and 30. Fine. Next operation is pop. Look at the algorithm. If top is equal to minus 1, it means stack underflow. Else, remove the topmost element, decrement top. Fine. Yes, the same is being coded. If top is equal to minus 1, print stack underflow. Else, print the deleted element is stack of top and then decrement top. Fine. Let us see an example. The current stack is 10, 20, 30, where 30 is the topmost element. If I call pop, 30 has to be removed. After being removed, the topmost element now becomes 20. So this is a very important operation, push and pop. Fine. There is another operation called peek. We will see peek soon. So key takeaways: push means inserting an element at the top of the stack. Pop means removing element from the top of the stack. Fine. Moving on to peek operation. Peek simply returns the top element. If your stack contains 10, 20, 30, peek returns 30 without removing it. Fine. Look at the peek operation. If top is equal to minus 1, I am printing stack empty. Of course. Else, print the top element, which is stack of top. Yes. This is how I am displaying the stack. So I call the display function. If top is equal to minus 1, I print the stack is empty. Else, inside a loop which says int I equal to top, I greater than or equal to 0, I minus minus, I am printing the stack elements. So this is how I display the elements inside a stack. Right. Let's look at the efficiency. Push takes order of 1. Pop takes order of 1. Peek also takes order of 1. And display takes order of n, because we need to visit every element, right? Yes. So stacks are almost used everywhere in computer science. Whenever a function is called, its information is stored in the call stack. Recursive functions use stack memory. Compilers use stacks to check whether braces are balanced. Stacks help convert and evaluate infix, prefix, and postfix expressions. Applications like your MS Word use stack to implement undo and redo functions. Every web page you visit is pushed into a stack. When you press back, the current page is popped and a previous page is displayed. Algorithms like maze solving, Sudoku, n-queens also use stack. Fine. So today we learned what is a stack, we understood the LIFO principle, we understood push, pop, peek, and the basic implementation using arrays. We also understood the time complexity and few real-life applications. Stack is one of the most important data structure because many advanced topics like recursions, trees, graphs, compilers, and operating system depends on it. In the next video, we will learn implementation of stack using linked list, and we'll also solve interview questions based on stacks. Thanks for watching. Happy learning.